So rational and irrational in numbers in maths doesn't mean making sense or not making sense. The word ratio in these means fraction. So rational numbers are fractions or can be written as fractions. Now fractions of whole numbers actually, because if I sneak the square root of 2 into a fraction, that's cheating. Are fractions or can be written as fractions. Now there's a whole bunch of numbers that are fractions or can be written as fractions. So for starters, any fractions. As long as we haven't sneaked, like fractions with normal numbers. Don't put a square root in your fraction, that's cheating. Fractions. A half. Negative 1/3. Light changes there a bit, doesn't it? 1 and 1/16. They're all fractions, and the definition of a rational number is, look, you can write it as a fraction, so these are fractions. It's rational. It's got a fraction. The next sort of number that's absolutely definitely rational is any whole numbers, including negatives and including 0. 1, 132. 0, negative 13. Because any whole number can be written as a fraction by putting it over what? 1. Great, well done. No one in the last class answered that one. Any whole number can be written as a fraction, so can be written as a fraction. Great, whole numbers are rational. Now remember I said right at the start, the irrational numbers are just the decimals that keep going forever and ever without a pattern. So obviously fractions and whole numbers, we're not seeing things that are keeping going and going forever without a pattern. The next one, which is why we mentioned terminating and recurring decimals. Terminating and recurring decimals. So any of these are rational because you can write them as a fraction. Remember we wrote 0.3 repeater as 1/3. And a quarter was 0.25. So any terminating or recurring decimals can be written as a fraction, so they're rational. 0.3 repeater, or recurring using the notation, or 0.25, or 1.137. If your decimal ends, then I could write it as a fraction. 1.137. If I wanted to write as a fraction, remember I'd check how many place values, and I'd make that one whole. Let's do this one as an example. That would be one whole and 137 over 1,000, and you know it's 1,000 because we counted the 3 decimal places. So any decimal that stops, that terminates, can be written as a fraction. It might be a tricky one, and any decimal that's recurring has come from a fraction as well. Now that's pretty much all of them, but there is a sneaky little category, and this one's a bit hard. Any square root that comes out to a whole number, any square root which equals a whole number or a terminating decimal. So these are a bit tricky because most of the square roots are irrational. Like if I do the square root of 2, I'm going to get 1.4 blah, 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 numbers going on forever. So most of the square roots, the decimals keep going forever, but if the square root works out to a whole number or a nice terminating decimal, like the square root of 25. What's the square root of 25? 5. It's 5. So if it evaluates to something that's rational, then it's rational too. What's another square root that would come out to a whole number?
36.
Yeah, square root of 36. That equals 6. So if your square root comes out to a rational number, then it's rational too. But that's a tricky sort of category. So those are my rational numbers. They can all be written as fractions, so they're rational. The only decimals in them that keep going forever are the recurring decimals, which are a nice pattern, and we saw that they came from fractions, so we should be happy about it. Any questions on my rational numbers? All I need to be able to do is identify them. So I write down a number like 0.6666 and I put some dots after it, and you say rational or irrational? Rational because it's a recurring decimal.
Would you put the dots on the top?
I would write it correctly. For people watching the video, I wrote 0.666 with lots of dots. That's enough to tell me that it's recurring. But of course I would write it correctly as 0.6 repeater, or recurring, and that would tell me it's recurring as well. Extra notes. So, irrational numbers. Now, they can't be written as a fraction of normal numbers. But we'll put another definition in as well. So you only put whole numbers in fractions. 1 over 2, 3 over 4. So you can't write these numbers as a fraction unless you get a bit tricky and put scary symbols in instead. But the easier way to remember is that the decimal part of the number keeps going forever. So in that way it's like our recurring ones because they keep going forever, but it never makes a repeating pattern for the rest of it. You never get to a point where you can say, okay, it's all 3s from here on in. That's an E. Never starts recurring. I mean, of course we reuse the same numbers. We've only got 10 digits. We've got to keep going for infinity. But it'll never get to a point where we can say, okay, it's all the same from here. So if you see a number that's got a lot of decimals numbers after the decimal point, and you don't see a pattern, chances are it's irrational. But none of these things that we wrote down before, all of those are rational. They're not irrational because all of those can be written as a fraction. So my irrational numbers are things like most square roots. Most square root numbers. E.g., square root of 2. Negative, the square root of 3. If you can see that it's going to work out as a whole number, like those ones, it's rational. If you can't see that it's going to work out as a whole number, chances are it's going to be irrational. Now, what was yesterday in the maths calendar? Pi Day. Pi is one of the most well-known irrational numbers. And what do we do on Pi Day?
8 pi.
What do we do mathematically?
Make fractions out of pi.
We don't make fractions out of pi because we can't write pi as a fraction because it's an irrational number, and we have competitions to recite the decimal places of pi, the digits of pi. Yes?
How many can you recite?
Off the top of my head, 3.14159265535 is as far as I get, and after that I have to stop and remember my system. And that keeps going. I'm totally not cheating. 3, 5, 8, 7. It's on the back wall. It keeps going. Like you can see on the back wall, we've got rows and rows and rows, but the people who can recite the most digits can do something like 100,000 decimal places of pi. So
Is there any pattern?
it never falls into a recurring pattern that you can not easily work it out. They've got to just remember the numbers. And how do they figure out the numbers? There's a whole bunch of stuff that does happen. But if you get pi, going off topic briefly, if you very, very, very carefully measure the distance around the outside of a circle, C, circumference, and you very, very, very carefully measure the distance across the middle, D, the diameter, then for every single circle anywhere in the world, even if it's right around the world itself, if you do C divided by D, you will get pi. So it comes from dividing the circumference of the circle by the diameter to calculate more and more and more digits. There's lots of big computer programs and stuff like that. But this is very important when we start learning about circles. However, right now it's just a funky, irrational number, and you have to know that pi is irrational. There are other numbers like it that are also irrational and have their own special names and symbols, but this is the only one we need to know at the moment. And any other numbers where you can't find a repeating segment, such as the tricky one I put up, I think, before. What's wrong with this? I don't have one segment that keeps going forever. There's a pattern, but it's not a repeating segment. So that'll do.